Hello and welcome to today's session. What we're going to look at today is an exam style question. So we've got the guidance from AQA and we know where the majority of the marks are coming for on each paper. So what I thought I'd focus on is a current electricity question that also links with paper 3, which is required practical 5. So required practical 5 is about the resistivity of a wire. So that's a question we'll look at today. So let's look at the question. This is the question. So we've got a piece of metal shaped into a rectangular block, and you're given the dimensions of the block, and you're also given the value of the resistivity of the block as well. So on your formula sheet, we've got the equation for resistivity. So we know that R, the resistance, is equal to rho, resistivity, times the length over the area, cross-sectional area, A. So resistivity, that means we're looking for this equation on our formula sheet. Part A, we need to find the minimum resistance. And it says in the question that the resistance of the block depends on which pair of faces it is measured between. So if we look at our equation for resistivity, we know rho is a constant. That means resistance is proportional to the length over area. So if we want the minimum resistance, we need the shortest length, so small l, shortest length, and the largest area. So that's why this question is 4 marks, because we have to think about initially what lengths and areas we're going to use to get a small value for R. So looking at the dimensions, what do we need to see? We see that would be the smallest length, and the largest area would be this one here. So the electrons travelling through a small distance and a large area, that will reduce the resistance. Then it's just a case of using the equation. So we've thought about which dimensions we're going to use, these here, and we plug into the equation. So R is equal to rho L over A. Resistivity is given. We need to make sure that all the lengths are in meters. So all the dimensions are in meters. So that length of 0.6, that needs to be in meters. So 0.6 times 10 to the minus 2. And the area that we're choosing, so 4 centimeters, so 4 times 10 to the minus 2 times 4.0, because there's 2 significant figures, remember. 4.0, we need to keep that consistent. 4.0 times 10 to the minus 2 times 0.80 times 10 to the minus 2. And it's the same for this. Everything's 2 significant figures. It's important because we know that on the paper there's a mark for significant figures. So if we keep it consistent in the question, it's going to mean that we won't fall into that trap of putting it to an incorrect number of significant figures. So put that into your calculator. We need to put that into your calculator, and we need a value to 2 significant figures, and we also need the correct unit for resistance, which is the ohm. So that's all we need to do. So plug all these numbers into your calculator. And 2 significant figures, we get a value of 8.1 times 10 to to the minus 3 ohms. So that's part A done. Part B. What is a maximum current in the block when connected to a 0.05 volt supply of negligible internal resistance? So for this one again, what do we need to use? We can use our equation. It's in the electricity section. We know V is equal to IR. We know that from GCSE as well. So I is equal to V over R, and from part A we've calculated the minimum resistance. So if we've got the minimum resistance, that's going to give us the maximum current. So 0.05 divided by 8.1 to 10 to the minus 3. That's going to give us our value for current. So for current, again, to two significant figures, we have a value of 6.2 amps. So what can be the challenge in the electricity questions, current electricity questions, is just figuring out which set of dimensions we're going to use, especially if you've got a resistivity question, or if it's going to be a bit more in depth. So thinking about the, you might have questions with resistors in parallel, resistors in series, and so on, and thinking about the combinations. So before you even substitute numbers in, think about what the question's asking, think about the proportionality of what each equation is trying to show us. What relationship is it trying to show us? So the next question is this one, and this is the last one we'll look at. And what I want you to do is complete a past question on resistivity. So that will be available for you in Turnitin. So just complete that and submit it via Turnitin. Right, so next question. We've got a filament lamp. It's connected to a DC supply. The current in the lamp is 2 amps when the potential difference across it is 12 volts. When operating at 12 volts, the filament of the lamp has a cross-sectional area of 4.9 times 10 to the minus 9 meters squared, and the resistivity of the filament material is 5.6 times 10 to the minus 7 ohm meters. And the question wants you to calculate the length of the filament in centimeters. So we've got these key points in here. We've got current, we've got potential difference. So that means we can calculate the resistance at that particular value of current. We've got the cross-sectional area, and we've got the resistivity. So what I would do, I'd think about the equation. So we know R is equal to rho L over A, and we also know that we know V equals IR, so R is equal to V over I. So if we find the resistance first, using V over I, because we're given the potential difference at 12 volts, given the current, then we can use our resistivity equation, and what can we do? We can make L the subject. So if we make L the subject, L is equal to R A over rho. So first thing we need to do, we'll do this first of all, find the resistance, then use this. So that's what we'll do. So part 1, find the resistance. Straightforward. R is equal to 12 over 2, gives us 6 ohms. 6.0 because it's 2, so 6.0 ohms. Second bit, find the length. So we've got the resistance and we've rearranged the equation for this, so in this form, and then all we need to do is plug our values in. But the final bit is that it wants the value in centimeters. So we just need to make sure we put that in centimeters. So if you leave it in meters, you'd lose a mark. So length is equal to resistance, so 6 times the cross-sectional area, 4.9. That was 10 to the minus 9. That is all over the resistivity, which is 5.6 times 10 to the minus 7. That gives us a length of, if we put those values into our calculator, let's do that now. So I get this on the calculator. So 0.525. So this is the unrounded value, and remember this is in meters, but the answer has to be to centimeters. So in centimeters, what is that? To two significant figures, we need it in centimeters, so that length is just 5.3 centimeters. And that's everything. So that's all we need to do for this type of resistivity question. And then again, if we link it to the paper 3, what did we do for resistivity? In the resistivity practical, if you remember, we had the resistance, we calculated the resistance, so resistance ohms for different values of length, so length in meters. So you would have a table like that, and then if you recall, we plotted a graph of R versus L, and we got a straight line, and we used the gradient. So remember, we always use the gradient in required practical, so this is required practical 5, RP5. Then the gradient is equal to R over L. From the equation for resistivity we can calculate it, but in the practical as well we also measured the cross-sectional area. So we also measured the area. So to find the resistivity rho, all we had to do was multiply the gradient by the area. That is because we know this equation here, this equation, resistance is equal to rho L over A, which means resistivity is equal to the resistance over the length times the area. So that's how we calculated it experimentally. And remembering for paper 3, you might have to talk about the uncertainties, so uncertainties in measurement. You also may be asked to talk about measurements, so measuring the area. So remember when you use the micrometer, the measuring of that for the diameter, so we measure the diameter across 3 sections as a way of controlling it. And a paper 3 question, as I said, it could be to, this is what I said in the lesson, it could be to calculate values in a table, or you could plot points on the graph. And remember in the table, when you're taking an average of results to exclude the anomalous result, because in the question that we did in the lesson there was an anomalous result, you have to exclude that. Also with the data points, you might have an anomalous result, so you'd have to circle that if you were asked to plot the particular graph. Okay, so that's everything I wanted to cover today. The question that you need to try will be on LearnZone, and then you need to submit it via Turnitin. It's just a question on current electricity. If you've got any problems drop me a message via Teams or send me an email and I will get back to you. Right, thanks for listening. I'll see you on the